In this video, we're going to consider the difference of two squares. Now, this is normally associated with quadratic expressions and quadratic equations, quadratic curves, everything in that category. But it is actually useful in other areas as well. So, first of all, in quadratics, if we were asked to expand this double bracket, x plus 3, x minus 3, you would follow the usual procedure. X times x makes x squared. Positive x times negative 3 makes negative 3x. Positive 3 times positive x makes positive 3x. And positive 3 times negative 3 makes negative 9. And we now simplify these two terms here, and we get x squared minus 9. Which perhaps I'll write like this. The point is that the negative 3x and the positive 3x cancel each other out to leave 0x, which we don't need to write. Now, this happens every time you have this structure of two brackets that are pretty much identical, except that one of them contains a plus, one of them contains a minus. This is known as the difference of two squares because it produces the square of x, the square of 3, and the difference between them, the difference of two squares. Now, once you get used to recognizing this format, you can use it in a number of situations. If we're asked to factorize this, all we need to do is recognize that we have the square of x and the square of 4 and the difference between them. And we hardly need to think. We can just write x plus 4, x minus 4. It's always wise to double check by re-expanding. X squared, positive 4x, negative 4x, negative 16, it works, and we have our answer. It can also be used numerically. 6.71 squared minus 3.29 squared. Now, doing that without a calculator looks horrendous. 6.71 squared is going to be about 40. But there's going to be 4 decimal places in the answer. And 3.29 squared, that's going to be about 12 or 13, but again, there'll be 4 decimal places in the answer. And then we're going to have to subtract them. That's at least 3 fairly lengthy calculations that we'd rather not do if we can help it. If, however, we recognise that we're looking at the difference of two squares, then we can write it like this. Which doesn't look much better until you realise that this bracket actually makes 10. So all I need to do now is work out 6.71 minus 3.29. Take my time, do it carefully. 3.42, so that's 3.42. And the answer, all of a sudden, is 34.2, exactly. You can check it on a calculator yourself. And so occasionally you will see the difference of two squares popping up in that sort of context. Going back to algebra for a moment, sometimes it's a little bit more hidden. 4x squared minus 36. You need to recognise that here we actually have the square of 2x and the square of 36. Or, if you preferred, you could actually go to there. You could factorise it like that first, and then continue factorising using the difference of two squares. There are different ways through that particular problem. Lastly, for this video, I want us to look at the difference of two squares when surds are involved. Now, to understand this properly, you'll need to have watched the introduction to surds, in particular a video on expanding brackets with surds. But this is now going to be very useful when we're trying to rationalise the denominator. Now, what have we got? 3 times 3 is 9. A positive multiplied by a negative is going to be a negative. Negative 3 root 2 plus 3 root 2. And then lastly, positive times negative makes a negative. Root 2 times root 2, which I think for the moment I will just write like that. Now, it shouldn't surprise us, given everything we've said about the difference of two squares. But these two terms are identical apart from the signs. They combine to make 0. And so what we've actually got is a final answer of exactly 7. You wouldn't believe it looking at the first line, but the answer is actually exactly 7. And that's going to be very important, as I say, when we try to rationalize the denominator in the second, more complicated video.